Welcome everybody. My name is Jason Grant. I'm going to be your host for today. It is, by the way, Wireless Friday. So if you had a bad day, just remember it's Wireless Friday. It's a good day. We have something to lean back on. We have a really great event planned today. Today we have a special guest speaker, Patrick Croak, who is a CCIE multi-time presenter at Cisco Live. In fact, one of my favorite Cisco Live presentations he did, but don't tell him that because you might get an ego. We are here today using WebEx Event Center. So if you've met with Cisco or any of Cisco's partners, you may be familiar with WebEx Meeting Center. This is WebEx Event Center. It looks really similar. However, there are some differences that you might notice. One of which is you were muted when you came in. So we did that on purpose so that we don't have, right now, by the way, we have 193 people attending, and I'm so excited about that. This means that we picked a topic, either a topic or a presenter or a time or all three that seem to work for a lot of people. So I'm really excited about that. If you are having problems seeing or hearing, well, if you're having problems seeing, hit us up on the chat panel. If you're having problems hearing, you probably don't hear me saying this, and I hope that you hit me up on the chat panel. If you have any questions along the way, questions whether it's regarding the content or regarding the delivery of the content, hit us up also on the Q&A panel. We'll try and hit all of the questions. If a bunch of people ask the same kind of questions all about the same time, I might even interrupt Patrick as he's talking to address it live. We will have time at the end to do Q&A, and I expect we'll be done probably before the top of the hour. So thank you for joining us. We are recording this session. The recording will be made available via a link that I'll send to you. Anyone who is registered for this event will receive the email with the link. You can also go to cs.co/wirelessfriday, and I will post the link there. Before we get started into the content, I want to let you know that your opinion of today's session really matters to us, and we want a 5. I know, obviously, it's really hard to kind of go, hey, you know, I never give 5s, right? Well, I want a 5, and if you can see us and hear us well, give us a 5. If the content met your expectations, give us a 5. If you can hear us well and the delivery was concise and the model was good, give us a 5. And if we didn't earn a 5, would you please let us know? I'll be building a poll. It'll be right in this WebEx Event Center, and I'll open it up about maybe halfway through the bottom of the hour, and you'll have an opportunity to hit it. It's really simple. If you have any ideas for topics that we can hit for future sessions, please let us know. Now, with this said, I'm going to go right to the punchline. So normally when you tell a joke, you wait for the end to tell the punchline, but I'm going to tell the punchline early, and I worked this out with Patrick, so I'm not stealing any of his thunder. But the topic for today is all about Wi-Fi optimization. And Wi-Fi optimization is really kind of comes down to 5 main categories: roaming, client density, overhead, and cost reductions. And you can kind of see here, and I'll send this list to you, right? So this list isn't anything super special, but when we think about roaming, we want to do things like turning off the lowest data rates, and Patrick will talk about this a little bit later, but it really affects how client devices are roaming around. And then there's also some really cool features that might be proprietary or unique, things like the optimized roaming feature, part of HDX, or fast transition, which is 802.11r, and our adaptive fast transition capability, which kind of solves some problems. We can get into that later. Things like radio resource management, tune that. And there's ways that we can tune it and turn on some of the things that are off by default, things like event-driven RRM and band select. A new and interesting technology called flexible radio assignment specifically addresses the issues of the very much increasing client density and the fact that we need more 5 gigahertz radios and fewer 2.4 gigahertz radios simply because of spectrum availability. Things like consolidating SSIDs, and we can use things like AAA override to do that. Multi-user MIMO, which today probably doesn't have a huge impact, but as you start to progress and as more client devices come on, multi-user MIMO will be more and more interesting. And then, we'll be talking about things like cost reductions, like the kinds of cost reductions that you can get from utilizing Wave 2 access points, and then migrating to a licensing style called Cisco One. So I've reserved about maybe a minute and a half to maybe 90 to 100 seconds at the end. I want to kind of give it an honorable mention. If you have any questions about this, certainly hit the Q&A panel. A good time for a next step, or a good suggestion for a next step is maybe just schedule a deep dive with your partner or with Cisco. With that, I'd like to turn the mic over to CCIE and multi-time Cisco Live presenter Patrick Croak, who's going to give us a demonstration.
Not quite that kind of demonstration, Jason. Could you go ahead and send me the ball so I can share my screen?
It is on its way. I guess I have to hit the OK button in order to establish that, but
all right.
Have it now.
Okay. Can you guys see my screen? Am I sharing?
You are. Looks
all
good.
Right, perfect. Okay. Welcome everyone this afternoon. As Jason mentioned, my name is Patrick. If you have questions as we cover some of these topics, just drop them into the Q&A panel and we'll either answer them real time there or Jason may stop me. We're going to cover several topics today about some optimizations you can make on your wireless LAN controllers to improve the performance of your environment. What I wanted to start with today, though, is something that maybe not all of you have seen before. We do have a new dashboard on our wireless LAN controllers as of the 8.1 code release. So if you're running older controller code, this interface may not seem familiar to you, but we've done a lot to improve the ability to digest information quickly. So when you log into the wireless LAN controller on the newer versions, you do get dropped into this dashboard. You get a very quick summary of the health of your environment, how many clients are online, what are your top WLANs, how much usage they have, and then we also have things like application visibility. So this is one of the items we will touch on a little bit later, but we do have our NBAR packet inspection engine running, and we can see what types of applications are running over the environment. If you have applications that you do not want to be running, we obviously have the ability to block them. We can also remark DSCP values based on a priority system. We can also see our top client users here and our top access points, the busiest access points if you're looking and trying to plan for additional density. Real quick, I just want to show you guys what information we can gather here. All of this is housed inside the controller, but what we've done in the dashboard is make it easier to consume. So here we have a list of our users, and you can filter on a specific username if you would like. We can also sort ascending or descending based on perhaps usage if we're trying to figure out who's utilizing the most bandwidth. So I'm going to go ahead and just drill into one of these users real quick to show you some additional information. So here, once we dive into a username, we can see this is running a Microsoft operating system. They're on our Blizzard network, which our Blizzard is our internal corporate SSID. We have a connectivity chart here to see it. If this user was having an issue, what step in the connection process were they failing at? So we obviously go through an association, and then we have authentication. In this case, it's going to be 802.1x to a Radius server. We then have the DHCP handshake, because of course we need an IP address, and then that connection is fully established. So here this user is up and operational, and we do have a chart here that's showing their top applications. This particular controller is running in one of our developer buildings out in San Jose, so that you'll see lots of various VNC and SSL traffic. We also get a topology of how this connection is flowing throughout the environment. We see the Microsoft workstation here, their IP address on VLAN 260. Obviously, they are connecting on the 5 gigahertz radio here to the access point, which then has a CAPWAP tunnel back to the controller with the given IP addresses. So it's really nice and easy to see kind of the traffic flow here. And if the client was anchored, if there were some layer 3 or inter-controller roaming actions happening, we would also see those tunnels built in here. Moving down, we can see their QoS policy. Here they have a platinum QoS level, which means voice and video traffic will be permitted at the appropriate DSCP values. And we can see which encryption scheme they're running. The last things I wanted to show you real quick, we do have some additional tests. We can run ping tests right from this screen, as well as perform a packet capture. The packet capture utility is something new in the 8.3 release, if you're wondering why you're not seeing that tool. Okay, so now I'm going to jump back into what might be a more familiar interface for everyone. It's now called the advanced section, where we actually configure a lot of these settings. And I'm going to walk through several of the key things that I see out in the field when I'm evaluating wireless health. The first one I want to cover, and Jason already kind of mentioned these in his summary slide, is the data rates. Okay, so when you go into the 802.11 BGN network settings, we're going to go ahead and see the data rates listed here. Now, the default data rates on the wireless LAN controller software does have all of these data rates enabled, even the very low data rates, 1 megabit per second, 2 megabit per second, those will be enabled with a default configuration. The reason for that is there are, believe it or not, still legacy devices out there, and we would prefer to allow those devices to connect if you have them in your environment than block them at immediate installation. But what's important here is we need to fine-tune these data rates. The most important piece of it is if you do not have 802.11b devices in your environment, we need to disable those 802.11b data rates. Those rates are going to be 1, 2, 5.5, and 11. 6 and 9, even though they're lower than 11, that's actually part of the G protocol. And you'll see here that we also have those disabled. So why would we disable these lower data rates? Number one, wireless is a shared medium. So if you have really slow devices talking, all of your fast devices, that brand new 802.11n, because AC doesn't run on 2.4 gigahertz, but I'll talk more about 5 gigahertz later. If you have an N device and it has to wait for a B device to transmit, it's going to slow everyone down. That B device is going to take a large amount of time to send that data. So it's going to reduce the whole speed and bandwidth of your access point. Additionally, we want to limit the range that clients can connect to this access point. So the data rates can be, it's a direct function of distance in where they can be demodulated from. So a 54 megabit per second beacon, for example, will only be demodulated closer to the access point. Whereas if you have 1 megabit per second enabled, a client will be able to see that beacon from very, very far away. And it's for this reason why you might see devices connecting to an access point on the other side of the building or the other, down a long hallway, rather than the AP still right above them. They can still hear those low data rates, and therefore they're going to remain attached. One key thing to remember is that clients dictate the roaming logic. The client determines when to roam. So if that client can still hear that slow data rate and thinks that connection status is fine, it might hold on to that access point. Now, there are some optimized roaming techniques that we can turn on to try to force the client to roam. But at the end of the day, the roaming logic on the device vendor has the final say. So we want to disable those low data rates because number one, again, it improves the efficiency of the cell because you have faster speeds being transmitted. It also makes sure that clients are attaching to the right access point. And then the management frames, which I'll talk more about later, but the management frames, which are going to be beacons and other frames, are sent at the lowest mandatory rate. So here with this configuration we have, those beacons would be sent at 18 megabits per second. The default settings have them being sent at 1 megabit per second. And I'll explain why that's really important a little bit later on. So understand data rates. You don't want to get too aggressive as you make changes. For example, you don't want to turn off everything except 54. That would not be the first step, right? Here we see 18. I typically start with 12. And then if you can move up and you want to keep reducing your cell size, you can continue to eliminate some of the lower speeds. I'm next going to move into our radio resource management capabilities. So The radio resource management algorithm is the algorithm that runs and it assigns channels and power levels to all of your access points. And this is done automatically. The algorithm runs by default every 10 minutes, and it's going to automatically assign channels that you have set in the channel plan. This algorithm, we've had it for many years and we've optimized it, so it works works very well in almost all environments, but there are some corner cases, and I'm going to talk about a couple examples where we need to fine-tune this algorithm. What I wanted to show you here today is we do have a new option called best in the channel width. So as you guys may be aware, channel bonding occurs when we combine two adjacent channels to improve the bandwidth. This concept was introduced in 802.11n, where we could channel bond to 40 megahertz wide. With 802.11ac, we can now channel bond to 80 megahertz wide channels, or four adjacent channels. With Wave 2, we also have the ability to do 160 megahertz channels. You'll see that option here, but it is not practical given the amount of frequency or spectrum that the FCC has allocated in 5 gigahertz. So you won't really see that in enterprise deployments. But what we do have is we have the best algorithm, and this was introduced in the 8.1 software. And what it does is, rather than forcing you to choose which bandwidth to run throughout your environment, the algorithm will take it into account. It's going to measure the spectrum around the AP and determine how much available bandwidth and frequency is there. So it might assign a 40 megahertz channel to one AP and only a 20 megahertz channel to another. And it's going to do this dynamically for you, and it's really a nice improvement to the algorithm to give you the best available bandwidth without causing co-channel interference. You also want to take a look at the DCA channel list. So here, these are the channels that will be assigned by the algorithm. You'll notice that we're missing several, which is the Uni2 extended channels. It is typically recommended to turn those on so you get more bandwidth, but before doing so, you should make sure that your legacy devices support all of those extended channels. There are some older devices that do not support certain channels, and you also need to be aware of the DFS requirements that the Uni2 channels require. So that's DFS, again, is the radar detection. If we detect radar, we have to vacate that channel. So if you're nearby a shipyard or a Navy base or an airport, you can sometimes get a lot of radar events. So be aware of your environment. And then the last thing I want to draw our attention to here on this page is the event-driven RRM. So this is part of our clean air capability. We have that spectrum analyzer built into the AP that can recognize and classify malicious interference. And while I mentioned this algorithm runs, the channel assignment algorithm runs every 10 minutes, event-driven RRM, if clean air detects an interference source, it's going to automatically change that channel without waiting for this algorithm to run. So you do want to enable event-driven RRM if you have clean air access points deployed. That's going to give you this ability to instantly mitigate interference sources. I'm going to talk about the transmit power control algorithm. This is the second component to radio resource management. So the transmit power control algorithm is the one that determines which power level your access points are running at, be it maximum power, which is 100 milliwatts and 2.4 gigahertz, or very, very low power. The algorithm works based on the number of neighbors that the access points see. So if I see a lot of neighbors nearby, a very strong signal strength, this is a dense environment, and I'm going to turn my power down. This algorithm, again, works very well in most environments, but there are some special use cases that I want to discuss. And one thing I should mention, the power levels are inverted to what you might typically think. So power level 1 is actually maximum power, and then power level 7 or 8, depending on the AP model, would be the minimum power. So what you might see, and I'm going to use an example here of a warehouse or a manufacturing facility. You install the access points at the ceiling, and all the access points at the ceiling, they don't have any obstacles between them because the shelving in the warehouse does not go all the way up to the ceiling. The racks don't go all the way up there. So you install the APs on the ceiling, and the access points hear a lot of neighbors because there's no obstructions between them, right? So one access point might hear 15 neighbors, for example. When that occurs, the algorithm thinks it's a very dense environment, and it does shrink the transmit power levels. Now, if those APs are mounted, at a 30-foot ceiling, that low transmit power is going to have a problem reaching the ground level. So what we sometimes need to do, and rather than statically assigning a higher transmit power, what I typically do is I come into here and I set the minimum power level assignment in this scenario. What we can do is I typically set it, I start around 11 dB. You can sometimes go to 14. And what that would be is the equivalent of somewhere around power level 3 or 4. Depending on the channel that you're on, there's a couple of different nuances there. But 11 or 14 is kind of where I start and see if things balance out. You do want to let the algorithm run several times, again, every 10 minutes, to see how everything balances out when you make a change. But this will allow us to increase the lowest power level that is assigned. So that's one example where this algorithm can be tuned. There are several others. Basically, what you want to do is you want to look at what your power level assignments are. If you see everything at power level 7 and 8, that might be okay if you have an ultra high density environment, but if you think you have some coverage problems because of that, we can modify this algorithm. Now, historically, these changes to these algorithms were applied globally at the controller, which meant you'd have to have the same settings everywhere in your environment. Luckily, we do have a nice thing here called RF profiles. So RF profiles are directly tied to AP groups. So when you define a set of access points in a group, you can also apply an RF profile to that group. These RF profiles happen to have the same settings that I just showed you. We can set different data rates, as well as transmit power control and DCA channel width. So with this RF profile, now, let's say you have an office space and you have a warehouse, you can have two distinct sets of RF parameters because those are two very different environments. All right, I do want to mention here, while I'm talking about radio resource management, and Jason alluded to this, I'll show you an example of it here at the end, but we do have our new flexible radio assignment algorithm on the 2800 series access points and the 3800 series access points. So when we talk about these ultra high density environments, we typically run into a scenario where we have redundant 2.4 gigahertz coverage. So traditionally, access points had a 2.4 gigahertz radio and a 5 gigahertz radio. What we've seen in many environments, you deploy a dense 5 gigahertz environment, and the 2.4 radios, there's only 3 available channels, 1, 6, and 11, and there's just simply not enough, there's too much coverage to allow all those 2.4 radios to broadcast or be turned on. So we end up selectively turning off some of the 2.4 gigahertz radios, which basically is a waste of a radio. So on the new 2800 series and 3800 series, we have the ability to flip that radio into 5 gigahertz mode. And what that looks like, real quick, I'm just going to show you, and let me move this around. If we go to configure a 3800, you'll see the radio role assignment here under that radio. We can have this set to auto, or we can set it manually, so that that radio resource management algorithm will do this automatically for you. It'll determine, do you have extra 2.4 gigahertz radios that you don't need? It'll flip these into dual 5 gigahertz mode. We have 2 sets of antennas on these APs, and we can then effectively double the capacity of the access point. So we can manually set it if you want, or you can let radio resource management do it. But here is the ability to set that frequency based on what your client density is. This is not part of 802.11ac. This is a Cisco proprietary feature that we have implemented. All right. Now I'm going to go over to some WLAN settings that you guys should be optimizing or looking at. I'm going to go ahead and select our Blizzard SSID, that's our corporate SSID, just to show you some of the settings we have enabled here. Under security, we want to make sure we're using the most advanced encryption methods, which is WPA2 with AES. Obviously, we prefer to run 802.1x instead of pre-shared key if you can. That is more secure, but be sure you're running WPA2 with AES. Not only is that a requirement for the higher throughput data rates, but it's also more secure. So be aware of that. The other topic I want to talk about is fast transition, otherwise known as 802.11r. So 802.11r is a fast roaming technique. It's actually the first full standards-based fast roaming technique we've had. There were some various key caching mechanisms that we could deploy earlier using some of the WPA protocols, but this is actually an extension of 802.11. So 802.11r effectively allows you to authenticate to your next access point before you terminate your connection to your existing access point. It really cuts down in the roaming times and allows for a secure authentication mechanism. Now, you can either turn this on or turn this off, which is disable or enable. The problem with turning this feature on, when 802.11r is enabled, there are a significant number of legacy devices or simply certain operating systems out there that do not like the 802.11r flag being set. As such, they may struggle to communicate or connect to the access point, or the SSID rather, when you have 802.11r enabled. So for a while there, we were recommending you had a separate SSID set when you needed to enable 802.11r. That caused additional SSIDs, and I'll touch on why you want to consolidate SSIDs here in a second. So what we've done is we also have a third setting called the adaptive setting. And what this does is this negotiates automatically certain clients that are 802.11r capable without broadcasting that feature set to the legacy clients. For example, Apple devices, when they connect, if we set this to adaptive, they connect to the SSID, they will get 802.11r support, whereas legacy devices will not. So this is kind of the best of both worlds. We're now allowing 11R for the clients that support it, and then still being compatible for the older devices. As I move through these settings, we go to the QoS tab. You'll see that our corporate SSID here is set for Platinum. It has voice in parentheses there. So historically, we recommended that Platinum was reserved for your voice SSIDs. However, with the amount of real-time applications that we're seeing, voice and video, it's critical to allow applications like soft phones or web conferencing from your corporate assets on the corporate SSID to use those Platinum voice queues. So one thing to note, it is recommended if you have real-time applications on the SSID to set this to Platinum. This does not remark every packet as a voice packet. This quality of service profile acts as a ceiling, meaning it allows packets to be marked all the way up to voice. But if you have random, background traffic or best effort traffic, it's not automatically going to be applied up to DSCP EF for expedited forwarding. So understand exactly what this QoS profile means. Moving over to the Advanced tab, there's several features here I want to talk about. We do have the AAA override option here. This is going to allow you to do things like dynamic VLAN assignment. This is very useful from an identity services engine perspective. You can pass users into different VLANs on the same SSID, allowing you to consolidate a number of SSIDs if you had different SSIDs set up for different groups. The reason you want to consolidate SSIDs, if you remember I talked about those beacons that were sent at the lowest data rate. Those are sent 10 times a second, or once every 100 milliseconds for each SSID. So if you have six SSIDs in an environment, you're sending 60 packets per second at the lowest mandatory data rate, just in beacons. I've seen that if you still have 1 and 2 megabits per second enabled, I've seen that completely utilize the channel in some environments because there's so many beacon frames being sent. So in addition to fine-tuning those data rates, we want to consolidate the number of SSIDs that are advertised. It reduces the management overhead. And AAA override with ICE dynamic VLAN assignments is one way to help you do that. In general, there's not a hard set rule, but my recommendation is to try to stay at 4 SSIDs or less. There are obviously certain environments where that is more challenging, but that is kind of the guideline. All right. I wanted to talk about 802.11k. You'll see this on the bottom left. 802.11k is another assisted roaming capability. That allows the access point to send a list of neighbors to the client so that the client already is aware of potential good roaming candidates. So the client does require, the client will need support for 11K to take advantage of it, but it is another technique in which we can allow or assist the client in those roaming decisions. If we go back up here on the right side, I wanted to talk about load balancing and band select. So here are two additional features that we do have. So load balancing, what is it? Basically, this feature is very useful if you say, let's say you have a large auditorium with an access point near the front door and then several access points throughout the room. All of the clients will walk through that front door when they initially walk into the room, and they're going to attach to that AP at the front door. That access point might get saturated. You might end up with 100 clients or more on that front door AP, where the access points in the rear of the room or the other sides of the room might only have a handful of devices, because the clients can still see that initial AP as they spread out throughout the room. So load balancing allows the system to say, hey guys, I have 100 clients here and there's an AP over there with 10. You should really go somewhere else. And it allows us to try to balance out some of that client activity. I will mention there are some drawbacks to enabling this feature, so there's a reason it's not turned on here. If you do have voice applications running in the environment, and that voice call roams to an area where load balancing would come into play, it can cause issues because the client will get redirected to a different AP and it will delay the roam. So there are certain environments where it makes a whole lot of sense to turn this on, but then there are some pros and cons here, so just understand how the feature works before you enable it, and you can fine-tune it. You can set a minimum and maximum of the window difference on how the load balancing algorithm works. Client band select. So this is an important feature that I do recommend for most environments. Basically, clients choose if they want to connect at 2.4 gigahertz or 5 gigahertz. 802.11ac only runs in 5 gigahertz. For all purposes, 2.4 gigahertz is a dying technology. With 3 channels available, lots of interference sources, Bluetooth, microwave, and limited bandwidth, we want to move clients to the 5 gigahertz spectrum. Now, unfortunately, the client decides which one to do. And some client logic, even though it's getting better, still says, I want to attach to the strongest signal strength that I have. Well, due to the laws of physics, 2.4 gigahertz signal travels farther than 5 gigahertz. So the client's going to hear that 2.4 gigahertz signal and say, hey, that's the strongest one I've got, I'm going to attach there. We don't want that to happen. So what we do with band select is we say, if we detect a client is probing on both frequencies, we will then stop responding to them on 2.4, which effectively forces them to use the 5 gigahertz radio. A nice feature to improve your client mix between 2.4 gigahertz and 5 gigahertz. All right. So I mentioned SSID consolidation already. Again, we want to keep that within 4. One other thing I wanted to show you, and I'm going to go back to the home screen. A lot of these things I've talked about, we realize, and we've done evaluations of a number of deployments and a number of various, let me actually go here. Various customer deployments, we've looked at their configurations, what's working well, and we have a best practices section. So best practices in wireless is a bit of a misnomer because every environment's unique, but we have learned several things as we've looked at configurations across different verticals on what works well and what doesn't. And what we've done is we've consolidated that list for you. This is, again, in that dashboard. So if you're not seeing this, you're probably not on 8.1 code or newer. And it does give you a list of the various things that you can turn on. So here, application visibility. Application visibility is not enabled. We can either fix it, and it takes us right there to do so, or we can say, you know what, ignore that best practice. I don't want to turn on that feature. Additionally, controller high availability, right? Do we have redundancy enabled, right? Is there a backup controller set? We can manually configure this right here from the screen. And then there's also some security best practices, as well as some RF management. So I was talking about the dynamic transmit power control, the dynamic channel assignment, right? Do we want to have these enabled in our environment? If they're not, maybe we should go ahead and do so. So this tool kind of helps us wrap everything together and enable some of these best practice features. All right, Jason, that's what I had covered on my top list of tips here. I'm sure I've been seeing some questions coming in and out. Are there some questions that we haven't answered or some topics that we should readdress?
That's a great question. Patrick, there are about 10 different people answering questions, and so a lot of them I think have been answered. There's some common ones. So one question, and this might be putting you on the spot, and I think if I were going to put anyone on the spot, it'd probably be you, because you probably would know this question right off the top of your head, but you talked about the packet capture feature. And that packet capture feature seems cool. Is it something that's available in FlexConnect mode?
You are putting me on the spot.
And maybe so, like I said, might be putting me on the spot. And maybe for those who are not familiar with that term, could you just briefly describe central/local mode and FlexConnect mode?
Sure. Yeah. So what we were talking about was basically back in the client section. There's the packet capture utility. So FlexConnect mode, traditionally controller deployments, all of the traffic is tunneled back through the controller, right? So you have all your clients, their VLANs, their IP addressing schemes are attached to a layer 2 trunk off of the controller. The control traffic and the data traffic is all tunneled back to the controller. If you have remote sites where you don't necessarily want that data traffic to come across your WAN links back to the data center, right? You have some local services or you have some direct internet access. We go ahead and flip those APs into FlexConnect mode. What that allows us to do is separate the control plane from the data plane. So the control traffic, managing the APs, configuring the APs, that all happens tunneled back in the cap lab to the controller. But the client data traffic itself is dropped right there locally on the switch in the VLAN that you define. So FlexConnect is very useful for those remote deployments where you don't necessarily want to tunnel the traffic back. So the question is, the packet capture utility that captures client information on the AP itself, does that work in a FlexConnect mode? I want to say yes, but I'm not 100% sure. So I believe because the capture happens on the AP itself while the packet's being processed on the radio. So in theory, it should be available even in a FlexConnect model, but I'm not sure if that packet flow, because it's being locally switched, I can't give you 100% on that, but we can maybe follow up with the answer once we know for sure.
Patrick, that proves once again that I shouldn't have been an attorney because I should have known the answer before I asked the question. But yeah, absolutely. We can follow up on that. There have been some other questions. I think that a common theme among them is something to the effect of, hey, I'm on my own controller right now and I don't see that feature. Is there, like, say, maybe a variant of code that you would recommend for a particular situation? And you know, what's that? How do I reconcile there's these cool new features versus I want to run a code that's known stable and not, just out of the oven?
Absolutely. No, excellent question. So yes, there are a number of feature sets available. And what I showed you today, the controllers I was using, they were on the latest 8.3. So if you don't see some of those options, that's probably why. Again, these are lab controllers and internal developer controllers. In production, you're wondering, which code should I run? I recommend that we bookmark this TAC recommended errorless builds page. And I don't know, do I have the ability to paste that to everyone, Jason? Or maybe someone could do that? I'm not sure.
Do what? Sorry?
Could someone paste this link? Either I can do it, or if one of the other panelists knows the page I'm on, can we broadcast that out to everyone?
In fact, what I'll do is I'll just include this page in the follow-up email so
Okay.
that it is available for everyone.
Yeah, so when you go to look at code recommendations, historically there might be a gold star next to a release when you go to download code. Those stars are not necessarily updated very quickly. So what we do is we actually recommend you go to this page that TAC, TAC processes thousands of calls. They figure out which codes, have certain bugs and which codes are more stable, and then they publish their recommendations. So you'll see here that there's a list of recommended builds from 7.0 all the way up to the latest 8.3. And there's a number of reasons, why you might be on a certain release over another. For example, it depends what access points you have in your environment. So if you still have, 1130s or 1240 series APs out there, they will not go past 8.0. So for those environments, I would recommend the latest 8.0 release, which is 8.0.140. If you have new controllers, the 5520 or the 8540, they have to be on 8.1 or later. Now, 8.1 is no longer under development, so I don't recommend 8.1 anymore, but I would recommend the latest 8.2 for those controller deployments, especially if you have the newer 2800 and 3800 series access points. We are very close to our next release of 8.3, which is going to have a lot of stability fixes, as well as another maintenance release of 8.2. So keep your eyes peeled for those over the next couple weeks. Those will likely turn into the latest recommendations for the newest code. But bookmark this link. We'll get it out to you guys. It's a very useful way to kind of sift through which code versions you should be deploying.
Thanks, Patrick. I'm going to take the presentation over for just 1 second here, if I might. And we'll hit one more topic and then dedicate the rest of the time to Q&A. Except I have to do it right here. On delay. So another thing that we talked about early on was making efficient the cost of your wireless network. Now, one of the things that Cisco's done, and one of the things that we've recognized, is that the way we approach software licensing is a lot like the way we've approached selling hardware. And selling software the way we sell hardware doesn't always work. And we took a multi-year effort, or we took a look at this, and we went through a multi-year effort to kind of correct that. The result of that is something called Cisco One. One is all in capital letters, but it's not an acronym. But Cisco One is a way for us to take hardware and software and separate them. So when you get hardware, you get hardware. When you get the software, you get software. The nice thing about that is, unlike in the past, where you have, like, say, a 5508 500 or 5508 100, but you don't really have 100 access points, you have 75 of them, right? So, the best cost-effective controller might be the 5508 100. Then when you go to buy maintenance for it, you're maintaining a 5508 100. So you really, always have more licenses really than you're using. With Cisco One, we don't have to do that at all. With Cisco One, we can say, okay, well, let's pick the best controller that makes the most sense for your deployment. And you get the controller, and there's a single cost for that, and there's no licenses associated with that. And then we just pick the best AP for the deployment, what makes the most sense. And then for as many APs as you have, you get that many Cisco One licenses. And that's those Cisco One licenses entitle you to connect any AP to any controller in perpetuity and impermanently. Right, so when you go to refresh your controller hardware in the future to whatever whiz-bang controller is out there next, you don't have to rebuy software. You already have it. And this Cisco One license also entitles you to prime infrastructure. We really didn't even get into prime infrastructure today, but it entitles you to both the lifecycle component of prime infrastructure, as well as the application visibility and policy control component of it, as well as the mobility services engine. And included in that is the identity services engine. Now, we have promotions going on right now that through the end of our fiscal year, we include things like a year of Stealth Watch for free. So that's going to be likely a topic of a future event. You get a year of Beacon Center Cloud CMX for free. We offer vouchers for professional services. So depending on the size of your purchase, we'll offer professional services vouchers so that a qualified partner can come in and install some of these great new interesting things. Now, I recognize that there's a lot of you out there who have made early investments in Cisco, and I thank you for that. And my family thanks you for that. And we do have programs to help give you give you credit for the investment that you've already made in Cisco wireless controllers, prime infrastructure, and then offer Cisco One, which is a completely portable and a license mechanism called right to use as opposed to node locked. And that's a story for another time. We can get you into that new thing. And the big reason why customers would want to do that is because now instead of having to maintain a controller that has more capacity than they really need, they're only buying what they need and they're only paying for maintenance for what they have. So that's Cisco One. More information is available on that from your partner from Cisco, and I think that's probably a great next step. A good next step, if this is a great appetizer for you and you want to do a deep dive, call up your Cisco account team or your partner account team, or certainly shoot me an email at jagrant@cisco.com. I will hook you up with someone who can go into a deep dive with this. Definitely talk to your partners about a Cisco One migration quote. If that makes, if you have non-Cisco One licenses, take a look at the costs associated with that. In some cases, the cost to renew maintenance actually absorbed the cost of the migrating to Cisco One. I will send over some links to a couple of deep dive sessions. One of them is kind of one of my favorite wireless LAN optimization sessions. It's actually Patrick, our guest speaker here, did a Cisco Live session in Las Vegas for 2 hours. He did just best practices for high availability in wireless LAN architectures. And if you thought that was cool, then follow that with Jim Florwick, who's probably one of the brightest radio minds in the country, who talks about advanced RF capabilities and capacities. That's another 2-hour session. We have a white paper called the Cisco Validated High Density Wireless Design Guide. Somebody came up with that great name. If you are a Meraki customer and you're doing cloud managed services, there is a variant of that, which is very well written, that covers Meraki methodology for deployment. And then I also want to pimp a blog article that I wrote called The 3 Steps to Tune Your Wireless LAN Controller, which is really the impetus for this whole session today. I wrote it a few years ago. I've updated it over time. And it surprises me how much of an issue this really is. This particular document has been downloaded, or at least viewed, more than 23,000 times. Check it out. It's not well written, but it's short. Where the white papers are about 80 pages, this is about 8 pages printed out, and that's only because it has lots of pictures. So check it out if you want more details. Now, panel. This is where I'm going to lean on you. If you have any questions that some of the participants have made that we can bring up, can you tune in now? And then participants, there is in your panel, right beneath our video, a little thing that will allow you to unmute yourself. If you have any questions, you're welcome to unmute yourself and just kind of say some verbally. I'll allow some time to get that done. Patrick, was there a setting in the wireless LAN controller network summary stats for time frame of the data? When you went into the dashboard, Patrick, and
yes,
you showed some of those graphs that showed My word, real-time data. What does real-time mean? What does that?
Yeah, excellent question. So yeah, on the wireless controller dashboard that I showed you guys, that is not necessarily going to be a configurable historical view. So it is, what is happening in the environment. Several of the graphs are actually what has happened in the lifetime of the system, meaning the uptime of the controller. If you're looking to figure out what happened in the last week or what happened last month, that is where prime infrastructure reports will come into play. So the WLC itself does not contain the historical data, but it does send all this information to prime where you can then extract the historical information.
Great, thank you very much. There's a great question in here about fast transition. A couple of questions about fast transition. I think that this one sums it up. When enabling fast transition, does the FT 802.1x option need to be enabled in authentication key management?
Yes, I believe you're referring to under the security settings on the SSID. When you enable fast transition, yes, you would also set FT 802.1x. I believe the exact terminology, I'm just hopping over to my settings. Yes, so you would set fast transition to enable or adaptive, and then you would set FT 802.1x if you're using Radius, or FT PSK if you're using a WPA2 pre-shared key.
There's another question that I think I'm going to take because I know the answer to it. Will the smart license be added to the 5508 code so that you can use that with Cisco One? And the answer is absolutely yes. So where the 5508 is a platform that uses a node-locked licensing scheme, and by that I mean the 5508, sir, it has a capacity of 500 access points, but only works within the capacity of the installed license base. So if you have a 100 AP license, that 101st AP is going to say, sorry, can't connect. We will absolutely allow you to use Cisco One licenses on the 5508, but understand that platform is still node locked, so we'll still have to kind of go, okay, well, we need a license file to install on that 5508. We'll still do it, you're still entitled to it, but that's a limitation of that platform. The 5520, in contrast, it uses a different licensing scheme. It uses a licensing scheme called right to use. With a right to use licensing scheme, the 5520, in that case, it has the ability or the capacity to support 1,500 access points. And when I go into the licensing section of the GUI, it just basically says, how many licenses do you own? And I type in a number. So it's right to use. It's kind of like honor system. Now, the 5520, in contrast, when I have 100, when I tell it I have 100 licenses and the 101st AP comes on, the 5520 will connect that 101st AP without a problem. However, it will kick off a message saying, hey, you're consuming more licenses than you tell me you own. Now with smart licensing kind of takes that to the next level, where we can kind of create a kind of a type of bank account that's connected to your Cisco.com account, and in that we deposit all of your licenses. And the 5520, instead of saying, oh, I've got this many licenses, it would actually go to your smart account and say, I'm a 5520, I belong to this company, and I'm consuming 34 licenses. So if you have 1,000 licenses, it'll subtract 34 from that number, and you'll know if you are positive or negative. Now, of course, if you go in the negative and you start consuming more licenses, it'll still work. It'll still work. It just gives you the opportunity to kind of relegate that to a sales process that does not have to interfere with the technical and deployment process. So hopefully that answers that question. Here's a good question, Patrick. How do you crack WPA2? That was a joke question, but I thought it was funny anyway. Here's another, Patrick, good one. Is it recommended to disable AeroNet IE on an SSID?
Yes. So the AeroNet IE, that's actually one of the items in the best practices dashboard. In general, yes, we do see that being disabled, even though it's enabled by default. There are some legacy devices that do not like the additional information elements that information provides. It is still useful if you do have clients that are CCX certified. I'm talking things like the 7925 wireless phones, or if you have access points operating in workgroup bridge mode. There are still advantages that come from the AeroNet extensions, but for the most part, yes, we do see people disabling that feature because legacy devices or devices that don't interpret it simply cannot take advantage of it and may actually have a negative impact. Ultimately, the bottom line is if there's extra information that a client's not expecting, there's more chance that something's going to go wrong with that client. Whether or not that's a bug on their end or ours, it's easier to slim down some of that extra information should you not need it.
Patrick, I'm going to give you the option of deferring this one because it might require a longer answer. And if that's the case, we can certainly follow up with the couple of people that asked it. But some people are asking about changing the DTIM interval. Do you have any comments on that? When you do that, why you would?
Yeah, so the DTIM interval can be changed. Most commonly, we see it for voice deployments. Typically, we change it to 2. You can go even higher, but for those that aren't familiar with DTIM, basically it's the number of beacon intervals that we go through before devices come out of power save to check for additional packets. Simplifying things, of course, there's more to it than that. But by default, the DTIM is 1, so every beacon period, clients are coming out of power save. You can set that to 2 or even higher. In some environments, I wouldn't go too high because then clients are going to be sleeping for a longer period of time. But what impact does it have? It effectively increases the battery life of some of these voice clients.
That's great. That's great. I think we have hit all of the intervals. We certainly have hit the top of the hour. I want to thank everybody for joining in and letting us steal an hour of your time on a Friday afternoon. For those of you on the West Coast, it is now afternoon officially. And for those of you on the East Coast, it is practically evening. And so I appreciate your time. We still have a number of participants, so I appreciate you sticking around the whole time. That was great. Really appreciate it. A couple of follow-up items. The session is recorded. I will be getting the recording out to anyone and everyone who registered for the event. You'll get a link to the recording. It uses the WebEx Event Center recording service. I found that's a fairly robust service for recording. And if you go to cs.co/wirelessfriday, you will see a list of upcoming events. We've kind of landed on the 4th Friday of the month and designated that as Wireless Friday. There might be some changes here and there, but I have some preliminary event dates and we'll be opening up registration for that. You will not be automatically registered for the next event. However, I will be inviting anyone who is here today to the next event, and I promise that's the only emails I'll send out to this list. So thanks so much for everyone. Everyone have a great afternoon. Patrick, thank you so much for your time. Thank you to the panelists, and have a great Friday.